We have discussed about the formulation of the electromagnetic potentials V and A corresponding to the electric field E and the magnetic field B, starting from the Maxwell's equations. Okay, so we have defined these electromagnetic potentials. Now we will discuss a very crucial property of the formulation of these electromagnetic potentials that we have discussed. Okay, and actually this property is the key point towards the concept of gauge transformations. That means the concept of gauge transformations of the electromagnetic potentials is based on this property that we are going to understand. Okay, so let us discuss about this crucial property of the formulation of electromagnetic potentials V and A. Let us first consider the formulation of the vector potential A. Okay, and we have defined this vector potential A by this relation B is equal to curl of A, which is derived from the equation divergence of B is equal to 0, following this principle divergence of curl of a vector is equal to 0. And following this principle, we can write divergence of curl of a vector A is equal to 0, and comparing these two equations we can easily write B is equal to curl of A. Okay, so this is how we have defined the vector potential A corresponding to the magnetic field B. Now the important point is that this vector in this principle is an arbitrary vector. Okay, so this means that in this relation B is equal to curl of A, we have choose this arbitrary vector as A in the beginning. Okay, and we have defined this A as the vector potential A. Okay, now since this vector is an arbitrary vector, that means we can choose any arbitrary vector in this position. Okay, or in other words we can choose any arbitrary value of this vector A in this position to write down B is equal to curl of A. That means we can write B is equal to curl of A as well as B is equal to curl of A1, A2, A3, etc. Okay, now all these equations, okay, whatever B is equal to curl of A or curl of A1 or A2, etc., all these equations are related to the same equation divergence of B is equal to 0. Okay, and that means they all are connected to the same magnetic field B. Okay, since we are talking with the same equation divergence of B is equal to 0, and that's why we are talking about a same magnetic field B. Okay, so these all equations are connected to the same equation or the same magnetic field B. That means in writing down these equations B is equal to curl of A or curl of A1 or A2, etc., this magnetic field is not different. These all the magnetic fields are same. Okay, so this is very important point we have to understand. Okay, that means in writing down this equation B is equal to curl of A, this vector A is actually an arbitrary vector. Okay, arbitrary vector, and we can choose any value of this vector A1, A2, A3, etc. And all of them will satisfy the same original equation, divergence of B is equal to 0, and thereby they will all represent the same magnetic field B. So this is about the crucial property that we wanted to discuss about the formulation of this vector potential A. So we have understood a very crucial property of the formulation of this vector potential A, and this property is that in defining this vector potential A through this relation B is equal to curl of A, actually this vector potential is not a fixed vector. Okay, we can take any arbitrary value of this vector potential, and all these arbitrary values will represent the same magnetic field B. Okay, that means this vector potential A is not unique, okay, in this defining relation. There is arbitrariness in the choice of A. Okay, so we can take any arbitrary value of this vector potential here. Okay, and all these different values of A will represent the same physical field B. Okay, all the these different or arbitrary values will represent the same physical magnetic field B. Now we can see the exactly same property in case of the formulation of the scalar potential V also. Okay, that means the scalar potential V is also not unique like the vector potential corresponding to the field E. Okay, we can take any arbitrary value of V, and all such values will represent the same physical field E. Okay, so let us have a look on it. Okay, this is the equation curl of E plus del A del T, from which we have defined the scalar potential V. Okay, following the principle curl of gradient of a scalar is equal to 0, and following this principle we can write down curl of gradient of a scalar V is equal to 0, so that by comparing these two equations we can write down this quantity E plus del A del T is equal to gradient of V. Okay, and we have defined this V as the scalar potential. Okay, so now the important point is that, as before, in this principle curl of gradient of a scalar equal to 0, this scalar is again an arbitrary scalar. So it means that in this position actually we can take any arbitrary scalar. Okay, initially we have taken this arbitrary scalar as V, and we have defined it as the scalar potential, but in fact we can take any arbitrary scalar in this position. Okay, and they will all satisfy the original equation, or in other words we can take any arbitrary value of this scalar potential, say V1, V2, V3, etc. Okay, so they will all connected to the original equation, or in other words they will all connected to the same electric field E. Okay, and that means for the same equation or for the same electric field in this equation, for the same electric field E, we can take any arbitrary value of this scalar potential. Okay, that means in this defining relation, in expressing E in terms of this scalar potential, this scalar potential is not a unique potential. Okay, we can take any arbitrary value of this potential in this position, and all these arbitrary values v1, v2, v3, whatever we like, all these arbitrary values will represent the same electric field E. Okay, so this is the same property as we have found in case of the vector potential A. Okay, where the vector potential A was also not unique, corresponding to the magnetic field B in the defining relation B is equal to curl of A. Okay, thus we have found that this scalar potential V in this defining relation is also not unique. Okay, this scalar potential V is not unique. There is arbitrariness in the choice of V. We can choose any arbitrary value of this potential, and all the such arbitrary values of V will represent the same physical field E. That means any arbitrary value of this scalar potential V will represent the same electric field E.